Alright, we're going to review seasons. We're going to start with let's take a look at the Earth real quick and just kind of review some basic facts. So up in the upper left-hand corner, if you would draw the Earth, remember the Earth is tilted on an axis, so the axis kind of sticks out sideways out of our Earth. There's an imaginary line that separates the top half from the bottom half. We call these halves hemisphere. The top is the northern. The bottom is the southern hemisphere. This is the northern axis. This is the southern axis. If you were at this spot, you would say you were at the North Pole. This axis always points towards the direction of a star in the night sky. This star is known as the northern star, also known as Polaris. Alright, that was really important way back when people had to travel without GPS and they had to know their directions, and at night they could figure out where they were, what direction, via help from the North Star or Polaris. Okay, so we know that we have a northern and a southern hemisphere. Seasons are caused basically by the Earth's tilt on its axis. So by Earth's tilt, LT, sorry about that, Earth's tilt and it moving around the sun. And Earth, what do we call that movement of the Earth and the whole way around the sun? We call that a revolution, and Earth's revolution. But the major cause is a tilt. If our Earth wasn't tilted, we would have no seasons on Earth. Alright, so that a little bit basics there. Now let's go ahead and look at this diagram. And we're wanting to let's start with our favorite season. And our favorite season is going to be mine, because I'm doing this video. My favorite is summer. So what you need to pay attention to when you're looking at a seasons diagram, here's the sun, here's our Earth. You see that the axis always stays pointing in the same direction. In other words, it's always this way. It doesn't flop back and forth. It always goes in one direction as it moves. So we're looking for when the northern hemisphere axis or the North Pole axis points to the sun. And I know this is difficult for you guys. The Earth here is tilted to the sun. The Earth here is not tilted to or away from the sun, but basically the Earth's here and the sun's here. So the pole's not pointing to the sun. It's just pointing out into space here. Whereas in this diagram, this is the sun. In this diagram, the Earth is tilted this way towards the sun. So that's what we're looking for. So let's put little arrows extending to the right and just right out to this side perpendicular to that line we're seeing. So we're focusing on the northern hemisphere because here's our, you can see very carefully, look very carefully, you can see that equator here. Here's the equator. Here's where we live in the northern hemisphere. We're worried about what goes on up here. The southern hemisphere, by the way, always has the opposite season. So we might want to note that also. So let's write that out to the side somewhere. Southern hemisphere always has opposite season as compared to northern hemisphere. Okay? So there we go. So if you don't know those, let's think. So summer, the opposite of summer it's summer in the northern hemisphere, then it is, in the southern hemisphere, it is winter. If it is winter in the in the northern hemisphere, then in the southern it will be summer. If we're having fall, they're having spring. If we're having spring, they're having fall. Okay. So that gives you an idea of what the opposite is. All right, so back to our diagram. So here I see that the arrow points to the sun because I've extended all my arrows out to the right for the northern hemisphere. So if my arrow is pointing to the sun, that means my Earth, the northern hemisphere, is tilted to the sun. It means the northern hemisphere is experiencing summer. Nice and warm. We haven't gotten there yet, by the way. The first day of summer is June 21st or 22nd. I think this year it's the 21st. Every year it changes a little bit by a day. So if we're having summer, that means in the southern hemisphere, if you look carefully, the pole, the Earth now is tilted away from the sun. Their side is tilted away. So if we're having summer, they must be having winter. Always the opposite. Now, the way I like to do it is follow the path. Remember, the Earth revolves around the sun counterclockwise, so it's going this way. You can follow the arrows, show you that it's going this way. Remember, it takes how many days to make one complete rotation? One complete rotation. Oh, sorry, I said it wrong. One complete revolution, excuse me. There you go, can happen to the best of us. One complete revolution takes 365 days, so a year. Okay. All right, so from this point all the way back to this point takes 1 year. So let's see. So let's make our way to the next season. So if we know we're moving in this direction, what season follows summer? Well, after summer, we come back to school, and the next season that comes up is fall. Okay, so we have fall. It's called a fall equinox. And by the way, the summer is referred to, summer and winters are referred to as solstices. Okay, so if we're having fall equinox, the southern hemisphere is having exact opposite season, which would be the spring equinox. By the way, it's called an equinox because on these days all over the world there are 12 hours of daylight and a 12-hour nighttime period. And this is worldwide. Okay, that's why we call them equinoxes. So we got from summer to fall. Now we're going to the next season. The days are getting shorter and shorter. We see our northern hemisphere is pointing away from the sun. This is going to be the northern hemisphere winter solstice. And since we're having winter, guess what? In the southern hemisphere, they are having their summer. The date is approximately December 21. And guess what, guys? December 25th is right around the corner here, and guess what season they celebrate Christmas in the summer for the southern hemisphere? Okay. All right, so we've got to the summer, and now let's keep going. So the next season following summer is the one we're in currently, and that is spring. And for the southern hemisphere, it would be fall. And yes, these are the equinoxes once again, where you have 12-hour day and a 12-hour night all over the world. All right, so the date here is March 21st. We might as well add all the days in here. For our summer, the day is June. We had mentioned it. We didn't write it down. 21st. And it's every 3 months. So for fall, the date would be September 21st. Okay? So here are the basics. So you know it takes to make one complete trip. It would take 365 days or a year. You also have to realize that, let's say, if we wanted to go from summer just to winter, so from C to A, that would take 6 months, right? If we just wanted to go from A to B, that would be 3 months. So this is 3 months. From B to C would be 3 months, right? From C to D would be 3 months. And from D to A would also be 3 months. So you add it all together and you have 12 months. 3, 6, 9, 12. One complete year. Another thing I would like you to just kind of go over real quickly with you is that the shortest day of the year is when we are having our winter. So this is our shortest day of the year right here for the northern hemisphere because it's winter. And I know y'all all noticed that, right? The days are getting longer and longer right now because we're moving closer and closer to our summer. So as we move from winter to, excuse me, I did it backwards. Somebody should have stopped me. Okay, this was the summer solstice, excuse me. This is the longest day of the year. I thought we were at winter here. Longest day of the year, right? Summer, longest days. When we move towards fall, the days get shorter, meaning the hours of daylight get shorter. Moving towards winter, they get even shorter. Daylight hours decrease. Alright, so when we're there, we have pretty much the shortest day in the northern hemisphere is here for us because it's our winter solstice. It's the shortest day of the year for us. Because it's our winter. Now think about the summer in the southern hemisphere. That would be their longest day, right? Because they're having summer. Winter's our solstice, our shortest day. But as we move from this day, December 21st, to March, and you all know that, as you move from winter into spring, daylight hours are steady increasing. So now I'm just going to draw a little arrow up. Daylight goes up, so we get more and more daylight. And till we get to the longest day of the year, and that would be right here. So our daylight increasing till we get to our longest day of the year. Alright, so that's basically a recap of the seasons diagram. If you need any help or any further explanation, feel free to come and see me.